In this video, we're going to look at topic 6, example 1, understand compound inequalities. So the main question, how can you use inequalities to describe the sets of numbers graphed below? And in part A, we have an inequality here on a number line, and then the statement, this graph shows the solution of two inequalities. Right? So if you think about it, we have kind of a piece here on the left, and we have a piece here on the right. So the two inequalities form a compound inequality. And what a compound inequality is it's made up of two or more inequalities. Right? Compound, think like compound word, two words put together. A compound inequality is two or more inequalities. What we want to do is we want to come up with kind of something for each piece. So here, in this case, we have -3, and then we have a closed circle, and it's shaded to the left. So if we were to state this as an inequality, the x values would be less than or equal to, right, because it's a closed circle, so equal to. So x is less than or equal to -3. And then for the piece over here on the right, we have an open circle. It's going to be shaded to the right, and we have the number 2. And in this case, our x values are to the right of 2, so they are greater than. They're not equal because it's an open circle, so we would just say x is greater than 2. And in a problem like this, where you have two separate pieces and really one goes left, one goes right, they don't overlap, they don't intersect, they don't cross, they don't head towards each other, this is a compound inequality describing the statement or. So we would say, if we were looking at this number line and we needed to say something, we could say that x is less than or equal to -3, or x is greater than 2. All right, so it's one or the other. It's not both of them. Now in part B, notice that we have the two circles and they go towards each other, right? There's no arrows going outside. But if we were to think about them as arrows, if we were to think about this, that one would go to the right, and this one here would go to the left. They're both considered boundaries. All right, one of them stops the other one in a way. So this left one, we could say is x is greater than -4. Next open circle would just be greater than, no equal sign. And since it's going to the right, that's why it's greater. And then the one on the right here is, again, we would shade to the left if we were thinking about that by itself. So x would be less than or equal to, closed circle, +1. This example, my numbers fall in between, all right? And it matches up both of them. So if I have a number here, let's say -1, that -1 satisfies the x is greater than -4, and it satisfies x is less than or equal to 1. So since it satisfies both of them, an inequality like this is actually an end statement. So we would say that x is greater than -4, and x is less than or equal to 1. And as we get further into this, you'll see the differences between and or statements. But the idea is that, there is a difference. Our or statements are part A. They're heading in opposite directions. A number either satisfies one or the other inequality in the compound inequality. And in part B, with an end statement, whatever number satisfies one of them, it also satisfies the other inequality. Okay, it fits both of them. The end statements you could also write in this form, and you'll see this pretty frequently, where you have -4, the smaller value is less than x, which is less than or equal to 1. So you will also see this written out, and you'll actually see this quite frequently. So do be familiar with that, where you have a variable in the middle with numbers on the left and right sides with two inequality signs.